Hello, welcome to this lecture video. So today, we are going to discuss a static group comparison. So this is the figure that shows the static group comparison. So as mentioned in the previous video, so we are going to consider two groups if we use this. However, the group is static, which means it is an intact group or an existing group, and there is no randomization for us to come up with these two groups. So you are given here the figure that shows that the group will be given treatment group. So it is the corresponding letter for that is the X, while for the blank space here, it means that this group will be given the control group. And then after providing them or giving them the intervention, they will be given post-test. So we have here O, that corresponds for post-test or observation. And what are the questions that we can ask if we're going to use the static group comparison? So we will use the same topic, effect of blended learning and the performance of the students in mathematics. So just like with our other design, we need to ask the question, what is the performance of the students in mathematics? Because we want to know the effect in the performance of the student. So the effect will be measured based on the performance of the students. The next, you are going to compare the performance of the students in group 1 and in group 2. So unlike in the previous test, particularly the one group pre-test post-test design, the comparison is between the pre-test and the post-test, and we use paired sample t-test. While in this video or in this particular experimental design, since what we need to compare is the comparison between the performance of group 1 and group 2, then we cannot use the paired sample t-test because group 1 is not dependent to our group 2. So how will we identify what particular test can we use for this problem? So first, of course, we have to go to our data. So in this data, we are provided, so it's a dummy data, we are provided with 4 columns, wherein the first column is the student. So it corresponds to the number of the students or the assigned number to your students. Then group corresponds to the group where the students belong. So it can either be in group 1 or in group 2. So if we are going to scroll this down, student 1 to student 30 belong to group 1, while students 31 to 60 belong to group 2. So assuming that in group 1, it is the treatment group, so they are the students given with blended learning. While for group 2, it is students 31 and 60, so they are the students given with existing or traditional method that serves as the control group in this experiment. So the number or the total score is 30. So the post-test scores are provided, and also the percent score are also provided here. So it is just to recall, this is the converted scores into percent by dividing it to the total score, multiplied it by 100. Okay, so now how will we know what type of test will we use? So first, we need to consider the nature of the data. So what is the nature of our data? So our data is at least interval, or in particular, it is interval. Next, our data So we also need to check if our data is normally distributed or normal, because this is one of the important conditions that we need to consider for us to determine if we're going to use either parametric test or non-parametric test. So if we have sufficiently large enough number of samples, or if the data is normally distributed, then it means that we can use parametric tests. So based in the given data, we have 30 students in group 1 and 30 students in group 2, which means by central limit theorem, because we have sufficiently large enough number of sample, and we also have equivalent, so which means that our data is, or the data approaches to normal. So it is normally distributed. Next, what is the purpose of the test? Our purpose is to compare, and the comparison between group 1 and group 2 is independent. So this is our initial identification for our the nature of the data. So it is at least interval, it is normally distributed, and the purpose is comparison, and the two groups that we're going to compare are independent group, which means that the appropriate test for this is t-test for independent sample. So therefore, since our data is normal, our data is at least interval, so we can use parametric tests. Our purpose is to compare two groups, two independent groups. So t-test for independent samples is applicable. Independent sample is applicable test. But before we can use this, we have still to check the test of homogeneity or equal variances. This is another assumptions that we need to check. And to check this, we will use the Levin's test, or the test for homogeneity. So for us to test if we have equal variances, or if it is it satisfies the test for homogeneity, then we have to use online calculator for this. And the website, so I have here the website. So this is the website of the test. So if we're going now to our Microsoft, or rather in our Google Chrome, or you can simply type quick statistics calculator and you can find this website. So let's click this and locate our test for homogeneity. So we have here the Bin's test of homogeneity of variances. So as you can see here, we have other tests, and we can also find here the test that we actually want to use, or the test that is appropriate for our data. So t-test for independent samples. But right now in this video, what we're going to use is the Microsoft Excel. So what we need to do is to click the Levin's test of homogeneity, and then we are going to copy our data set here. So sample 1 corresponds to the data in group 1, and sample 2 corresponds to the data of group 2. So we will copy this. So anyway, it is also your option if you want to interchange this. It doesn't matter as long as you know the intervention given to the particular group. Okay, so let us just copy this and click calculate. Okay, so you are provided with all the things that you need, and you are also given the solution if ever that you're going to use the manual computation. But what we exactly need is the value below. So we have here the F ratio value is 8.02441. The P value is 0.6006337. The result is significant at P less than 0.05. And what is the conclusion? The requirement of homogeneity is not met because